Okay, this is our Exponents Part 2 video. Please make sure you have your notes so that you can fill them out as we go through the video. Pause the video when necessary so that you can stay caught up. Okay, to find the value of a power, or sometimes they call it to evaluate, which means to solve, you want to first write each number, each power in expanded form and then evaluate. So expanded form, it's like when you blow a balloon up, it expands, it gets bigger. That's what you're doing here. You want to expand this power and write it out long ways. So 4 squared, or 4 to the second power, to expand it, you would take the base and you're going to repeat the base as many times as the exponent tells you to do, which in this case it tells us to do it twice. So it's going to be 2 4s, we repeat the 4 twice, and the operation is multiplication. So when you expand it, you get 4 times 4. And then you just solve it. You do the math. 4 times 4 is 16. 2 to the 4th power. Okay, what is the number that you're going to repeat? It's the big base number, which is the 2. How many times are you going to repeat it? You're going to repeat it 4 times. So you're going to get 2 times 2 times 2 times 2. Now, to do the math, you just multiply. 2 times 2 is 4. Then you multiply 4 times 2 and you get 8. And then you multiply 8 times the last 2 and you get your answer of 16. Okay, our next one is a little bit different. It's 8 to the 1st power, to the power of 1. And we actually talked about this in our first video. How many times are you wanting to repeat the 8? You're wanting to repeat it just once. So it's just 8. You're not multiplying it with another 8 because you only want 1 8. Okay, 2 cubed, or 2 to the 3rd power, means that you're going to repeat the big number, the base, the 2, how many times? 3 times. The exponent tells you 3 times. So you're going to repeat the 2 3 times. And that operation is not addition, it's multiplication. So you're going to get 2 times 2 times 2. And when you do the math, 2 times 2 is 4. Multiply 4 times the last 2, and you get 8. And the last one is 5 to the 3rd power, or 5 cubed. Again, what is the number that's being repeated? It's the big base, the big number, the 5. How many times is it being repeated? Whatever the exponent tells you. The exponent is a 3, so we need to repeat the 5 3 times. And we have 5 times 5 times 5. Now this is a very common power, 5 to the 3rd power, 5 cubed. So it'd be good if you could memorize it. 5 times 5 is 25. And we want to multiply 25 times 5. So I always think of it as quarters, 25 cents. Well, if you have 5 quarters, how much money do you have? You have 125 cents. So 125. 5 cubed equals 125. Now here's a couple other examples that I want to talk about that are not in your notes, and I would like for you to add them to your notes. The first one is with fractions, 1/2 cubed. Okay, you'll notice the 1/2 is in parentheses. When I have 1/2 like this, written like this, 1/2 cubed like this, the cube, the exponent, it kind of looks like maybe it goes with the 1, that maybe you're just taking 1 to the 3rd power. And that's not the case. We want the whole fraction to be cubed. So when you have fractions and you're raising them to a power, you always want to put them in parentheses. And then the exponent goes on the outside of the parentheses. So when I expand this, the 1/2 is still your base. It's what's being repeated. So I'm repeating the 1/2, and the exponent tells us to repeat it 3 times. So it's 1/2, 1/2, 1/2, and of course the operation is multiplication. And to refresh your memory, we've learned when we're multiplying with fractions that you multiply your numerators together. So 1 times 1 is 1, and 1 times this last one equals 1. So our numerator is a 1. Multiply your denominators together. 2 times 2 is 4. Multiply this 4 times this 2, and you get 8. So your answer is 1/8. 1/2 cubed equals 1/8. When dealing with decimals, You don't have to have the decimals in parentheses. You can if you want to. It doesn't hurt with the exponent on the outside. Or you can just have the 4/10 cubed. Either way, it's the same thing. Your base is the 4/10. This is what's being repeated. How many times are you repeating it? The exponent tells us 3 times. So it's 0 4/10 times 0 4/10 times 0 4/10. And let's go ahead and multiply the first two 4/10 together. If you'll remember to multiply decimals, take out the decimal points. And let's just multiply. 4 times 4 is 16. Then go back. How many decimal places were there in your factors? There was 1 in each, so we need a total of 2 decimal places. So we get 1600ths. Then we want to multiply the 1600ths times the 4/10. So again, forget about the decimal places. Multiply 16 times 4, you get 64. How many decimal places do you want? The first factor had 2, and this 4/10 has 1. That's a total of 3. So there's 1, 2, 3 decimal point. You'll see I have a hole which I have to fill with a 0. So our answer is going to be 64 thousandths. Okay, what is the value of 5 cubed times 3? When you have questions like this, expand out your powers. 5 cubed is the same as 5 times 5 times 5. We know 5 times 5 is 25, and we just talked about when you multiply 25 times 5, think of it as 5 quarters, which is going to give you 125. Now that's not our answer because we still have this times 3. So we need to multiply the 125 times 3, and that's going to give you 375, which is answer choice B. Okay, let's go ahead and look at our foldable note for our journal. And let's just go through this. When you first learn, it's kind of a summary of what we've gone over in the first 2 videos on exponents. When you first learned multiplication, you probably represented multiplication using repeated addition in groups. We talked about that. 3 plus 3 plus 3 is the same as saying 3 times 3. Basic exponent operations can be represented by repeated multiplication. So if we have 4 cubed, we're just repeating this 4 3 times. 4 times 4 times 4. Do the math and you get 64. Over here, it shows us what our powers are going to look like. B to the nth power. What this means is that the B is multiplied by B in number of times. You're multiplying it by itself however many times this exponent tells you. The end is your exponent and the B is your base. If we have 1 to the 5th power, we're repeating the 1 5 times. 1 times 1 times 1 times 1 times 1. And of course, 1 times anything is itself, right? So the answer is 1. So 3 squared, if we expand it, what we're repeating is the 3. How many times are we repeating it? 2 times. So it's going to be 3 times 3, and 3 times 3 is 9. So when we say an exponent out loud, we call a number with a power of 2 squared, and a power of 3 is cubed. Okay, there's some special powers that we need to remember. The first one is that any number to the power of 0 is always going to be equal to 1. It doesn't matter what the base is. If it's 2, if the exponent is a 0, the answer is 1. 5 to the 0 power, or to the power of 0, equals 1. 1 to the power of 0 is 1. 25 to the power of 0 is 1. Excuse me. So again, it doesn't matter what the base is. If that power, the exponent, is 0, the answer is going to be 1. And any number to the first power is going to equal itself. 3 to the first power equals 3. 12 to the first power equals 12. 500 to the first power equals 500. Doesn't matter what the base is. If the power is a 1 or the exponent is a 1, then it's going to equal the base itself. Okay, now you're ready for your independent practice. You're going to do the try it. Oh, hold on. We're going to do one of these together. No, we're not. We're going to come back here. I want to go over one more thing. What if we had 10 cubed? When we expand it, we know it's going to be 10 times 10 times 10. And when we do the math, 10 times 10 is 100. Multiply this by 10 and we get 1,000. There's actually a shorter way of figuring this out. Whenever your base is a 10, all you have to do is write a 1, and the exponent tells you how many zeros you need. So we need 3 zeros, and that gives us 1,000. Isn't that what we just discovered? Let's try another one. What if we had 10 to the 5th power? You're going to write a 1, and then the exponent tells us how many zeros we want. We want 5 zeros. 1, 2, 3, 4, 5. Go back, place your commas, and you get 100,000. One more, 10 to the 11th. Again, you put a 1, and the exponent tells us that we want 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Go place your commas. These are the hundreds, the thousands, the millions, the billions. 100 billion is going to be our answer. Okay, now you're ready to go ahead and work on your independent practice. It's at the bottom of your exponents foldable. The try it. There are 6 different problems you're going to simplify. I want you to go ahead and expand them just like we've been doing and then solve. So 2 to the 5th power would be 2 times 2 times 2 times 2 times 2, and then solve it. You're going to do that for all 6 for the rest of the problems.